So I'm going to give you, I'm going to do two examples. We're going to do number 2 and number 7 together. I know a lot of you probably remember how to balance, or once we get started, it'll kick in, and you'll remember. I found this a few years ago. It's called the box method. It works really well as things become more complicated. I think it's also a great starting tool just to kind of refresh your memory. So in order to do those and make it a little easier to see, though, I'm going to do it on a piece of paper. So just to make things a little easier to follow. So on number 2, we have hydrogen peroxide. And it decomposes. We talked about that. That's why it's in a brown bottle. It decomposes into water and oxygen. So my job is to find the coefficients, the numbers out in front. And one of the reasons some people have trouble with this is that there's no one rule or one way to follow and balance all the time. Somebody might start on the left, somebody starts on the right, all those kinds of things. So the more you do them, the easier it gets. So with the box method, we're going to draw a box under each of our substances, and I'm going to break this down into the individual parts. I don't want the subscripts in there. I want to make it more visually appealing for my brain. Your brain is a visual organ. I want you to see what's going on. So we do that for the hydrogen peroxide. We do that for the water. And we'll do that for the oxygen. And so it's real easy then to look at what's going on. Remember, I have to have the same number of hydrogens on the left as I have total on the right. I have 2 on the left and 2 on the right. So we're good to go with those, correct? But oxygen, I have 2 oxygens on the left and I have 3 on the right. It's not balanced. So if I have more on this side's deficient, or it needs some more, the only way that I can add more to this side is to duplicate the box. I have to clone it. So I'm going to make another box, and I have to write down the exact same things in there. I can't make it fit what works for me. So anytime I add something, I have to clone a box. So now I have 4 oxygens. Well, great. I only have 3 on the other side. So here's where some people might try to add more oxygens first, and some people might try to fix the hydrogens. I'm going to fix the hydrogens. I have 4 on the left. I need 4 on the right, and I can do that by duplicating that box right here, adding 1 more water. So now I have 4 hydrogens, 4 hydrogens. I have 4 oxygens, and I happen to have 4 oxygens on the right. 1, 2, 3, 4. Now it's balanced. Okay? So we just count the number of boxes. I have 2 boxes, coefficient of 2, coefficient of 2, and a coefficient of 1. So I always highly recommend doing this at the beginning, even if you already know how to balance, because when the formulas become a little bit more complicated, you need something to fall back on. Okay? Questions on that? We good? Okay, let's look at number 7. On number 7, we're decomposing aluminum oxide into its elements. So once again, to get started, I have a dividing line so I know what's equal on both sides. I clone my box. I have to make my box a little bit bigger sometimes, depending upon my substance. Oxygen is one of those diatomic elements. It cannot exist by itself. It either has to be attached to some other substance, some other element, or it has to have its twin. Okay, so let's just Get people involved here. Pick somebody else. Virginia, where do you want to start? Yeah, let's clone one of the boxes to try to start equaling things out. What do you want me to add? Okay, we can add another aluminum. It gives me 2 aluminums on the left and 2 aluminums on the right. Lauren, what do you want me to do next? Okay, where and how? Which side does it not have enough? Okay, the left side doesn't have enough, right? Oh, I'm sorry, the right side. Okay, so since I have 3 on this side and 2 on this side, she wants to add some more oxygen. So I have to clone the box. Still doesn't match up, but as we go along, some of you will probably start seeing what's going to happen eventually, right? So it's just as easy to kind of go back and forth. I had 2 versus 3, now I got 3 versus 4, so now you need to add more oxygen on this side, but I have to add everything together. I can't just add a few. It gives me 6 oxygens and 4 oxygens, so what can I do to fix that now? Yes, add 1 more oxygen. That takes care of all my oxygens. But I have 4 aluminums versus 2. So I add 2 more of those. And now we're balanced. So the problem with balancing is you really just kind of have to work your way back and forth. Some of these you'll run into, there'll be an oxygen on every single reactant and product. And so it gets a little more complicated. We'll just see it as we go along. So we have a 2, 4, 3. One of the things that I kind of give you a heads up on, very seldom are you going to get one of these coefficients that gets much above 4. On a rare occasion, you might get to 6 or 8 if we're dealing with a combustion reaction. We'll talk about those as we go down the road. But if you're starting to get a couple, especially if you get more than one coefficient up above 4, you probably ought to stop and go back and make sure that you haven't made a mistake somewhere along the line. Okay? And also at the end, check if you did make a mistake, you might be able to reduce these down. They all might be multiples of 2 or 3 or something like that. So just kind of be aware of those possibilities.